suppose first order differentiable continuous function, and this axis star be the regular point, and suppose this is local minimizer of this objective function f not subject to the constant. This is a Lagrange multiplier, and second one is mu star, and this is known as a KKT multiplier. Okay, so both are vectors. If this is a belongs, if there are more than one equality constants and inequality constant, then this is the dimension is greater than one. So this is in that case is your vector. Okay. Otherwise, if there is equality constants is 1 and equality is 1, so that's why lambda and mu are real less. Okay, so that's why we here there are some conditions here. Mu star is always greater or equal to 0. This means mu star either 0 or greater than 0. And second is derivative of this objective function at x star lambda star transpose is equals to 0 transpose. Okay, and third one, mu star transpose, which multiply with your quality constant, that is f1 x star that equals to 0. So these three conditions, this is your main KKT theorem. This is a statement of your KKT theorem where lambda and mu are your Lagrange's and KKT multipliers respectively. Okay, so this is the theorem. Then we solve a problem which is based on that theorem. Okay, so on next page we which is based on this KKT theorem. Next page. So if we consider suppose the circuit, suppose if we here draw that circuit, suppose this is your circuit, suppose this is your resistance R. Okay, and here suppose there is some plus, this is minus, and this is 20-volt battery, and this is joined resistor R, and here your current flows. Suppose this current is I in the circuit. Okay, so suppose this is okay. So now consider the circuit in figure is given here. So you have to formulate and solve the KKT condition. KKT condition for the following problems. Okay, and the problem is basically first one, you have to find the value of resistor. So find the value of the resistor R, and you know that this resistance of any resistor is always greater or equal to 0, such that sorry, such that the power absorbed by this resistor maximized, and your negative theorem is valid on minimum. So you have to uh, reform that problem of maximization to minimization problem. And second, find the value of the resistor the power delivered to delivered to the 10 ohm resistor is maximized. Okay, so types of problem. Okay, so here you have to find the data resistance R. First one, the power absorbed by this resistor means this resistor R is maximized. Okay, and second one is we have to find that resistor R and the power delivered to this 10 resistor. This is maximized. Absorbed. So the power absorbed by the resistor R, which is greater than or equals to 0, uh, is is you know that this becomes if we divide by I square R, and what is the value of here current? So you know that by Ohm's law, you know that I equals to total volt upon total resistance. So this is the total volt is 20 volt, and this is V equals to IR. You know that is the form. Uh, that is equals to power. Okay, so this is to I into V. So this is your 20 equals to IR, so that's Y square R. Okay. Current here is the total voltage to resistance are connected in a series. Okay, so if two resistors are connected with in series, so you know that this plus this. Okay, if this is in parallel, so R equals to R is R1 plus R2. So here, you know, problem can be represented as the optimization problem. The problem is optimized problem can be represented maximize maximize. So if we transform this maximization problem to minimization problem, then your objective function is minus of that objective function. So minimize minus of objective function, and objective function is your power. Power is I square r. What is the value of I square? So this is equals to 10. This is square. This is I square, and this value. Okay. So now your maximization problem is reduces to minimization problem, and here you have to maximize. What is your maximize? Maximize. You have to maximize I square. Okay. This problem is maximization problem is reduces to minimization problem like that. Okay. And subject to constants, minus r is less or equals to 0. Okay, this is your inequality constants here. And no equality constants are given. Okay, this is problem with inequality constants. So either so here only for mu component is there due to inequality. Okay, and lambda component for equality constants.
Sir, hello.
Lambda and mu. But in this case, problem in which only inequality constants are given, and after that we take another problem in which both are given inequality as well as equality. Here, this is
Hello, sir. हेलो सर नेटवर्क प्रॉब्लम बहुत ज़्यादा हो रही है
of derivative of the objective function the derivative of the objective function is given as
प्रॉब्लम बहुत ज़्यादा हो रही है
this is 10 plus r whole square. Okay. So objective function, and if we derivative of that is equals to minus of okay, so denominator square, so this becomes and here this into this 10 plus r square derivative of numerator that equals to into 400 minus derivative of that into 400 r. So 2 is 800 r into 10 plus r. Okay, so if we take 10 plus r both sides and subtract to the
सर नेटवर्क प्रॉब्लम हो रही है
both sides. So this is
हेलो सर
बताएं
सर नेटवर्क प्रॉब्लम काफी हो रही है वॉइस क्लियर नहीं हो रही सर रुक रुक जा रही है इसके साथ हो रहा है ऐसा
वॉइस क्लियर नहीं है
Yes, sir.
और सर स्क्रीन रुक रुक जा रही है
Okay, so if we take 10 plus r here and cancel by this thing, this becomes 10 plus r. And if we try to solve this thing, this becomes minus 400. And this is 10 minus your objective function that is f0. Okay, this is your objective function. Okay, and this is function of basically this r. Okay, this is the function of x. Okay, so now here we find the derivative of that function. So this is your derivative of objective function r. Okay, so you find this thing. So now what is the So here KKT condition. So in next page, so here the KKT condition, thus the KKT condition. What is the KKT condition? So KKT condition is the is beta equals to 0, and second one derivative of f naught.
आपकी स्क्रीन
Okay,
पॉज हो
so
गई है
your screen.
सर वॉइस पूरा यस सर पॉज
सर
हो गई
स्क्रीन पॉज हो गई है आपकी
सर जो आपने लिखा है सर वो विजिबल नहीं हो रहा है मतलब बाद में लिखा है जो आपने
हमने एक दिख रहा है आपको, क्या नहीं दिख रहा?
नो सर
स्क्रीन तो हमें तो क्लियर दिख रहा है, इसमें प्रेजेंटेशन में भी क्लियर
सर बीच में पॉज हो गई थी स्क्रीन अब आपने जो नेक्स्ट पेज किया है तो अब आया है
वॉइस नहीं आ रही। अब क्लियर है, अब आ रही है, तो स्क्रीन विजिबल है सभी को। ओके, सो
अभी visible है।
कंडीशन ओके,
आपने जो नेक्स्ट पेज चेंज किया ना वो थोड़ा सा बैक कर दीजिए उस टाइम इसमें रुक गई थी
फोर क्यू। ओके, this minus and
सर
this lambda term is absent here. हाँ,
सर
बताएं।
लास्ट पेज दिखा दीजिए वहाँ पे आपका स्क्रीन पॉज हो गया था
लास्ट पेज देख लें, ठीक है। तो यहाँ से आपने डेरिवेटिव निकाल रखा है, दिस इज योर डेरिवेटिव। ओके, एंड here this function is your f1, this function is f1 and this is your objective function. Okay, so now the next page, if we go to next page, so the KKT is greater or equals to 0, and the second one is derivative of your objective function mu that equals to 0, and third equation is mu with r that equals to 0, and your inequality constant is minus r is less or equals to this condition. Okay, so what is the KKT condition? So KKT condition is know that what is KKT condition? So derivative of f naught at h x star plus mu star transpose with derivative of with inequality constants that equals to 0 transpose. Okay, third one is if we multiply here U transpose with our inequality constants star like this, and from this here derivative of that you can already find it, and this hx term is not there, so this term is due to no inequality constant is there, so that's why we absent this lagrangian multiplier here. Okay, so this term is 0, and now this term third here your inequality constant is minus of r is sorry, so this becomes mu in r. Okay, so what is the derivative of f1 r? This equals to simply minus 1. Okay, that's why if we multiply here this mu into minus 1. Okay, so this is the value of this term. Okay, so now that's why we write here minus mu that equals to 0. Okay, not transpose because the f1 r, what is the f1 r is your minus r. This is a minus r that equals to 0, or you can write mu r equals to 0. So that's what we write this thing. Third one. And this is already given. This is given minus r is just 0. Okay, so you have these 4 conditions. And now here we consider mu is greater than 0. We consider 2 cases. Suppose that, then suppose this is your equation first. This is minus 4,000 upon 10,000. So this becomes minus 4. Okay, and the second equation. Okay, so now we suppose this mu equals to 0. If we take mu equals to 0, second equation, then by the equation 2, we have
सर स्क्रीन विजिबल नहीं हो रही सर. हेलो
screen
सब विजिबल है बट आपकी स्क्रीन फिर से पॉज हो गई है.
सर बहुत ज्यादा नेटवर्क प्रॉब्लम हो रहा है. सर वॉइस भी नहीं क्लियर हो रही है.
स्क्रीन दिख रही है पूरी, स्क्रीन पूरी विजिबल है.
सर स्क्रीन दिख रही है बट लिख क्या रहे हो ना वो नहीं हो रहा है, वो दिख नहीं रहा अभी आगे का.
कहाँ इक्वेशन सारे दिख रहे हैं 1 2 3 4.
सर बट दिस यहाँ तक दिख रहा है, उसके बाद का नहीं.
कुछ भी नहीं दिख रहा, थोड़ी सी नेटवर्क की प्रॉब्लम है. तो
सर अभी वी हैव तक दिख रहा है सर.
बस वही तक लिखा है हमने. ओके, सो इफ हियर इफ mu इज ग्रेटर देन 0, इफ mu ग्रेटर देन 0 तो r इक्वल्स टू 0 हो जाएगा. और r अगर 0 है तो आप अगर यहाँ पुट करोगे r इक्वल्स टू 0 तो you equal what is the value of r. So we have in this case you get r equals to 10 here. So r equals to 10. So therefore, the only solution, the only solution to the KKT condition, to the KKT condition is okay. So this is the final solution. Okay, and what for your equation number for condition of B part? B part, the power absorbed by the resistor 10. So okay, so we start with our next page. Okay, so we go to the next the by the resistor, the power resistor 10 ohm, or okay, right, by the 10 ohm resistor, 10 resistor is, you know that power is formula is I square R, and here R equals to about 10 ohm. So where what is the current line? So your optimization problem. So the optimization problem can be written as, or can be represented as, homogenize minus of your objective function, and that is I square. This is square. This is 20 over 10 plus r. This is square into r, and that is r is 10. Okay, so this becomes a 400. This is 4000 upon 10 plus r square. This is the minus sign, and subject to the condition. Okay, so now you have to find the derivative of this is your objective function, and here this is your inequality constant. Okay, so now you have to find the derivative. What is the value of derivative here? So derivative equals to the derivative of right directly. This is 8000 upon 10 plus r cube. Okay, so what is your KKT condition? So KKT condition, the KKT condition is, you know that the mu is greater than or equal to 0. Here Lagrange multiplier is 0. So you take mu in your objective function. This is minus 1. This means mu equals to 0. This is in 1 second. And then mu r is 0. And your r equation number 1. This is 2. This is solution of this problem. Okay. So what is this here? So here we 0 or less than greater than 0. As before, we consider you can see there this mu is greater than 0. So then if mu is greater than 0, then r equals to 0. Okay, this is equation 3. Okay, the equation is here, mu greater than 0, so r equals to 3. Okay, so r r is greater than 0 or equals to. Okay, and second case you mu 2. So then what is the value of 2 equals to 0 in this equation, this thing? Okay, so what is the value of r? So r is negative. Okay, so here r is negative, so it's, this contradicts basically your condition 2. Okay, so this equation 2. Okay, so therefore only solution to KKT condition is r is 0, and when r equals to 0, when r equals to 0, to get mu equals. For both cases A and B, you have to present your problem in the you have to find the KKT condition and you have to solve that. तो आपको बस यहाँ एक ही चीज याद रखनी है कि आपको बस एक ही चीज लेके चलना है कि म्यू कंडीशन जो है दैट म्यू इज आइदर ग्रेटर देन 0, ये कंडीशन म्यू इक्वल्स टू 0 करके आप सॉल्व कर लेंगे. नेक्स्ट प्रॉब्लम इन व्हिच we can see in a problem which contains both type of equality constants. Okay, next page. Okay, so if you have to a problem so this is a problem. We have minimized our objective function, and that is x1 and x2, and that function is suppose x1 square, x2 square plus x1 x2 minus 3x1. Substitute x2 that both are greater than 0. Obtain, and you have to first of all you have to write a condition and then in the solution. Okay, so what is the KKT condition here? So the KKT condition condition problem is to show that what is the object function. The objective function is x1 square, x2 square plus x1 x2 minus 3x1. This is objective function. Okay, and what are the inequality constants? So f1 is basically minus x1 is less or equals to 0. Okay, and f2 is minus of x2 less or equals. So what is the KKT condition is? So first condition is this is mu, and here this is x1 x2. That's why your mu is basically to mu1 and mu2. This will belong R2. Okay, so this transpose is greater or equals to 0. So this is the question. First, second condition is derivative of objective function with mu transpose, and this is minus 1. One, what is the derivative of that? Is minus 1 minus 1. Okay, that equals to 0 transpose. And third one is your equation is minus of mu transpose of x, that equals to 0. And your fourth one is here this x is greater or equals to 0, x is greater to 0, x is greater 0, so x1, x2. Okay, okay. So your KKT condition like that. Okay, and what is the derivative of this derivative of that objective function? So we have what is the derivative of objective function? So objective function of x. So here, if we differentiate plus x comes 1 plus 2x2, and this is transpose. So this is the derivative of f naught x. Okay, so basically this gives you KKT condition. Finally, this implies that what is the KKT condition? So your KKT condition is plus x2 minus 3. Okay, so this thing derivative of that minus of mu1, because so mu is mu1, this is minus 1, that equals to 0. And second one is this thing, this is x1 plus 2x2, and here minus of mu2, this equals to 0, and is reduced to in this form. Okay, minus of this is basically product of this minus of mu1 and minus of mu2 is multiplied with x1 x2. Okay, so this transpose means okay, this, so this equals to 0. So this implies that uh, 2x2, and here this condition applies. Okay, so now the final KKT condition is, if you write on next page. So next page, so gives the condition is, okay, so here mu1 mu2 greater equals to 0. Okay, and second one 2x1 plus x2 minus 3 minus mu1, that equals to 0, and x1 plus 2x2 minus mu2, is 2x2, that is x1 is less or equals to 0, and x2 is less or equals to 0. So these are the final KKT conditions. Okay. So now we have 4 variables. You have to find out the conditions are here. Basically, from this condition, you Second condition, when but mu2 is greater. Okay. Third condition, when mu1 greater than 0 but mu2 0, and fourth condition is mu1 greater than 0 and mu2 greater than 0. Okay, so in this case, so mu equals to 0. Okay, so you have just four cases here. Okay, so now, okay, so here, if we take our case first, when 1 is 0 and mu2 is 0. So this implies, if we take from equations, okay, so which equations? So if we define that equation is suppose, okay, so suppose if you write this equation is 1, this is 2, and this is suppose 3. Okay, now because we have only this condition, so you marking that is also, so this is equation number A and this is equation number suppose B. Okay, so now, so from equations, if we write 1 and 2, so we get what is the value of x1 is here 2, and this -1 is not feasible. Okay, this is not feasible because our this x1 is greater than 0 and x2 is also greater than 0. So this means this is not feasible. Okay, so this solution is not feasible. Then we go to our case 2. Okay, so case 2 where mu1 is 0, mu2 is greater than 0. Okay, so now if our mu2 is greater than 0, so if we take this equation number 3, because mu1 is 0, so this is 0, and here from equation 3, okay, so you implies that your x2 is 0. Okay, so from this equation you get x equals to 0. Now, from equations, here if we put here x2 equals to 0 and mu1 equals to 0, then we solve that two equations. Okay, so from equation 1, we get x2 equals to, this is 2 and from equation 2 implies this mu2 is 3/2. This means your mu2 is greater than 0, and here x2 is greater than 0, and here not x2. I think this is x1, because x2 is 0 here, because x2 is this term is 0. Okay, so this is x1. This is x1. Now your solution is x1, x2 is equals to this is x1 is 3/2 and 0. Okay, this value, and what are your mu? Mu is 0 and 3/2. Okay, so this, and here your x is this transpose. Okay, so here you get x is greater or equal to 0, and also mu is greater or equal to 0. So this means your solution is feasible. Okay, case 2 is okay. If you to case 3, what is case 3? Case 3 is mu1 is and mu2 equals to 0. Okay, so this implies equation 3, from equation 3, this mu2 is 0, so this means x1 equals to 0 here. From this equation, this implies that x1 equals to 0. And now we're putting in these two equations from equation 1, this implies mu1 is -3, and from equation 2 implies x2 equals to 0. Okay, so here mu2 is -3, this is less than 0, this is not feasible. So this is 3 is also not feasible. Okay, so now goes to case 4. Case 4 is mu1 greater than 0, greater than 0. Okay, so now we find from equation 3, if both is greater than 0, then we can try to find the one value in the other. Okay, in terms of other. So see, for this implies we find x1 is minus of mu2 x2 over x1. Okay, so here, here this minus of x1 is less than 0 and minus of x2 is less than 0, and so we get mu2 is greater than 0. Okay, so this implies you get x1 is if 2 is greater than 0 and x1 is greater than 0, x2 is greater than 0, then you get x. This value is negative and this is infeasible. Okay, this is a this mu1. This is basically mu1 because this mu1 equals to minus of mu x2 over x1. So this mu1 is negative. This mu1 is negative. This is also infeasible. Okay, so this means you finally get the solution, and the solution is okay. So now, so now, what are the condition is mu is okay. Okay, so what is the solution is okay. So which condition satisfies? So I think this second one. Okay. Yeah, take care of the second one. So this is the solution in which you get the final solution. Okay. So here the physical point error which satisfies the okay. We write here the physical point. Physical point error satisfying the PPT condition. PPT condition is only that is x star that equals to this is x1 is 3 by 2 and this is 0, and what to mu star, so mu star that satisfies the condition that is 0 and 3 by 2. Okay, so this is your condition that is okay, so these are your physical solution. This is physical solution for your minimizer. The candidate, this is a candidate for minimizer. This candidate for minimizer. Okay, so this is your final solution. Okay. Okay. Tomorrow we will discuss that. तो कल हम वो डिस्कस करेंगे। तो आज के लिए इतना ही। तो बाकी हम कल ये सारी चीजें करेंगे और देखते हैं नेटवर्क का इशू अगर ज्यादा है तो फिर मैं डिपार्टमेंट से क्लास दे दूंगा। बहुत ज्यादा दिक्कत हो रही है या है आपके? है या नहीं? बताएं।
सर ये लास्ट में मिनिमाइजर लिखा है कि मैक्सिमाइजर लिखा है? लास्ट की लाइन सर बता दीजिए क्या लिखा है आपने स्टार्ट।
ओके, so this is candidate for और this is problem of minimizer है ना, तो इसमें minimizer ही लिखा है, ये minimizer है, ठीक है। क्योंकि प्रॉब्लम में मेरे minimizer की प्रॉब्लम है, that's why this is candidate for minimizer. और if your problem is a maximization problem and you reduces that problem to minimization problem, then if you have to find the value of your Lagrange multiplier and axis star, then that solution is your maximizer. Okay, and if your problem is already given in the minimization form, okay, then you have to find what is the value of x star and that thing. That's your candidate for minimizing. Okay, तो कोई प्रॉब्लम जो कि मिनिमाइजेशन की प्रॉब्लम है उसमें जो आप सोल्यूशन निकालोगे तो उसमें आप मिनिमाइजेशन ही, लेकिन यदि आपकी ओरिजिनल प्रॉब्लम अगर मैक्सिमाइजेशन की है, उसको यूज किया है मिनिमाइजेशन प्रॉब्लम में, तो अफकोर्स आप जो वैल्यू होगी पर किस वैल्यू की, जो आपने ट्रांसफॉर्म करके नया प्रॉब्लम लिखा है, लेकिन वो सोल्यूशन है वो आपकी ओरिजिनल प्रॉब्लम का क्या है, क्योंकि उसी प्रॉब्लम को आपने मैक्सिमाइजेशन को मिनिमाइजर बनाया है, तो देन दैट सोल्यूशन इज मैक्सिमाइजर ऑफ योर ओरिजिनल प्रॉब्लम। ओके, तो जो भी आप सोल्यूशन निकालेंगे वो आपका, अगर प्रॉब्लम मिनिमाइजेशन की है तो मिनिमाइजेशन की होगी, अगर वो मैक्सिमाइजेशन का है तो कैंडिडेट आपका मैक्सिमाइजर का होगा। तो यहाँ कंफ्यूजन नहीं रखेगी, इसे ऑलवेज हम मिनिमाइजर की बात करते हैं, लेकिन हमारा प्रॉब्लम जो मैक्सिमाइजेशन का है उसको मैं रिड्यूस करके नया फॉर्म बनाया है मिनिमाइजर का, तो हमारा जो